everybody. I hope you're enjoying the start to your 4-day weekend. Yay! I did just kind of want to remind you of your expectations for this Discovery Lab for Unit 4 for projectile motion. I did say it on Monday, but it's been a long week, a lot of things going on, a lot of things to remember. So I just wanted to kind of remind you of your expectations in terms of this entire packet. So Tuesday, the day that I wasn't here, that was the day that you were supposed to collect all of the data for question 1, and then was A, B, and C. Part C was really where you needed to collect a lot of data because you had to graph the data and then form a mathematical model. And then that's actually what we are going to present out on Tuesday, because we are going to be whiteboarding that information. The rest of the packet, that was kind of identified that you need to complete it using the simulation. So let's just take a quick look at what you're supposed to do with that. So that link for the simulation is in that document. Remember, this was on Tuesday's kind of instruction day in the checklist. So if we go into this virtual simulation from PhET, this is a PhET simulation. We could go ahead and launch that simulation. And then we collect a lot of data very easily, and quickly. All right, so here is the lab stuff. Notice that you can change heights, you can change the initial speed, you can change the angle. When you go ahead and launch it, we can go ahead and move this and see, okay, well, where did it land? What is that distance? What we can also do that's a little bit easier is take this time, range, and height tool that's up here and simply put it where we need to go. So we see the height is 0, the time it took from the moment of release was 2.07 seconds, and then the range, so that horizontal distance was 26.59. So my face might be blocking that, but that's what you see from this. You could also use the measuring tool. That is an option for you, but this is pretty nice because it can spot check pretty much everything, you know, what's happening at that maximum height, so on and so forth. If you really wanted to, you could change what you're shooting. So maybe you want to shoot a baseball. Whee! What happens? Exact same thing. So that is really all that you need to know for this simulation. Pretty user-friendly. You can change so many different variables. And then this simulation is going to help you answer all the questions beyond question 1. So starting at question 2, hypothesize. If you were to keep the velocity the same but change the angle, what happens to the range? And then you do have to test it. So you're going to do this in your notebook. If you haven't started already, don't wait until the last minute. Like, don't wait until like 11 o'clock Monday night to do this. Figure it's going to take you an hour to 2 hours maybe, because there are some tested and extension questions. So all of these questions need data. You're going to hypothesize, test it, defend your answer, and then you'll kind of just keep going on with given scenarios. So actually this given scenario where I tell you, hey, move it to 15, 30, 45, 60, and 75 degrees. Then I tell you several pieces of data that you need to collect. This is going to take you a little bit. But with the simulation, it's not going to be too bad because, again, with that little box that tells you time, range, height, it's not too bad to actually get the data. It's pretty quick. It's just a matter of doing it for those different angles. And then from this given scenario, that's where you're then going to answer the rest of these questions down here, because all of these are based off of the information that you already found. So you don't have to do retesting once you get to this part because you've already collected a ton of data that gives you everything that you need. And then the rest of these, I say, answer qualitatively. But if you prefer, if you want to say, hey, this is what I found when I looked at the given scenarios, or this is what I found when I looked at some of the other questions, the kind of bare minimum is qualitatively. But if you would like to put in numbers since you have them, feel free. Do notice that every single one of these says explain. Explanation means you have a sentence or two there saying, why did this happen? So don't just put like 1 or 2 words there. Do put a sentence or 2 to explain it. Then the very last thing, this is your free response question, where you're going to take a look at given data, compare it to what you found, and then say, are there similarities, differences, and as always, you have to write it in a paragraph length response and provide at least 2 similarities and differences between your data. Make sure that you have references to your data. This is something that can be typed or printed, but I highly recommend that you just type this. If you try to write this all out in your notebook, it's going to take a while. So just go ahead and type that. There will be an assignment in Canvas where you can go ahead and upload your free response. Really, all of this, just make sure that it's done before you come into class on Tuesday, because a lot of the questions that you see here, those qualitative ones, those follow-up questions, those are going to be questions that come up in the whiteboarding discussion, whether from you or from me, but they're going to be there, so you have to make sure this is done. I am probably going to check this as well to make sure that you have everything done and that you have it done too. A high quality, really meaning that you have a lot of data to support your answers. And then I will check the free response via Canvas. Now, just real quick, going up to, there we go. That question number 1, do make sure, so for this, like, you know, how much time did it take the object to hit the ground? Give us some reference point, like where did you start your object? Was it at the top of the table? What height was that? If you don't quite know, at least give me like some qualitative reference point, because some people, with me not being here, maybe you started on the floor. I've had people do that before where they just wanted to shoot it on the ground, and they looked at a very small distance that it traveled. Some people did it on top of a desk. Some people actually stacked books. So I need to know what that initial starting position is, because if you just tell me a time with no reference, I have really no idea what's going on. And then these 2 questions, so initial velocity of the ball, that was kind of easy, at least to test at first, because you could put it at short, medium, long range, or if you had the other one, you could even like measure, you know, if I pulled it back 1 inch, 2 inch, 3 inches, how did that affect it? But where you really had to make a decision, and this was probably a hard one to make, is when you had to determine the mathematical model between initial velocity, so that's what I gave you, as your independent variable, and range as your dependent variable. As of now, we have potentially 3 different ways that you could solve for the initial velocity. You have the constant velocity equation, and you have the 2 uniform acceleration equations. Whatever you choose in order to solve for initial velocity right now is a valid method. As long as you have reasoning behind why you chose that method, you're good. And then you will kind of explain that in the whiteboarding discussion on Tuesday, why you chose your equation in order to solve for that VI. What was kind of your reasoning? What was maybe a conceptual reason why you chose that? And then that will be part of the discussion. So and all of this, you are going, well, really, 1C, you are going to whiteboard on Monday, so you'll show your data, tell us the equation you used, graph it, which you will have already done, so put the sketch there, and put the model there. And then the rest of these pieces will just be in your notebook, except for the free response, which will be typed and submitted to Canvas, or if you do really want to write it out, you have to take a picture, put it in a document, and submit it to Canvas either way. But all of this should be done by the time you come in on Tuesday in your notebook and then in Canvas. So what I'd like you to do now, since this is going to be linked into an announcement in Canvas as well, everybody does need to watch this video, hopefully sooner rather than later. You do need to send me a confirmation email saying, hey, I reviewed your video. Thank you for the information, or thank you for the reminder to finish this. I understand that I do need to have this completed in full by Tuesday before I walk into the class. All right, I look forward to your email. I hope you have a delightful 4-day weekend, and I will see you on Tuesday. Bye, everybody.